Example 2 wants us to graph f of x equals sine of x minus 2. So remember that if we were looking at y equals sine of x, the range for this was from -1 to +1. And notice that if we have sine of x minus 2, where the minus 2 is outside of the parentheses, we are taking all of our range values and subtracting 2 from them. So the range of this thing is going to be -3 to -1. And the way that I got those endpoints is I subtracted 2 from each of these endpoints. So everything is basically being shifted down a total of 2 units. So here is -1, here is -3, and it's not moving horizontally at all. It's only being shifted downwards. So I'm going to go ahead and fill in my x-axis values. All right, so I filled in some of my values on the x-axis. Here I'm going to fill in -2 as well. Now, every instructor is different, but for my class, when you are graphing these, I would be happy as long as you're getting these 5 main points when you are talking about sine and cosine. So what do I mean by the 5 main points? Well, I know that if I evaluated f of 0, then we'd have sine of 0 minus 2, which ends up equaling 0 minus 2, which is equal to -2. So when I plug in 0, my output's going to be there. And when I plug in pi over 2, sine of pi over 2 is 1. And then subtracting 2 from that would give us -1. And just knowing the patterns of sine, I can go ahead and plop in these other values. And I know that my sine graph is going to look something like this. Like that. And that is just one period of the graph, but I am happy with just those 5 main points. And then, you can always continue on. The next x value would be 5 pi over 2. And it would look, I could put a dot here, and it would look, so on and so forth. So that is how we graph f of x equals sine of x minus 2. So now example 3, we want to graph g of x equals negative sine of x. And if you remember from pre-calculus, when you multiply a function by -1, that results in a reflection over the x-axis. And so I'm quickly going to fill out a table here, and I want to include those main values that I was referring to earlier, those 5 main values. So those values are 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now keep in mind that these values might change depending on what type of transformation you're doing. For example, if we do a horizontal shift, we are going to have different input values, but because we're only doing a reflection across or over the x-axis, the input values, the 5 main input values that we are looking at, are not going to change. So all we're doing is we're taking the output values that we would normally get and we're multiplying them by -1. So this is going to be 0, this would be -1, 0, +1, and this would be 0. So I'm going to go ahead and fill in those x values on the x-axis. So now I can start to plot my points. And so my graph is going to look something like that. And for comparison, let's say that this, in green, f of x is equal to our regular sine function. So if I continued on this table, and I plugged in the same x values, and I wanted to see what the output values for f of x would be, this is going to be 0, 1, 0, -1, and 0. And so on the same set of axes, I'm going to graph the f of x function in green, and so that's going to look something like that. And notice that it is indeed or truly just a reflection over the x-axis. So this is f of x equals sine of x, and in the pink we have g of x is equal to negative sine of x. And so that's how we would graph that type of transformation, where we have a reflection over the x-axis. The graphs of functions y equals sine of x minus b and y equals cosine of x minus b are sine and cosine graphs shifted horizontally by the absolute value of b units. They are shifted to the right if b is greater than 0, or to the left if b is less than 0. The number b is the phase shift. Now, in pre-calculus, you might have heard of what is called a vertical shift versus a horizontal shift. And in trigonometry, we call a horizontal shift a phase shift. So this is just another way of saying a horizontal shift. And this term is specifically used within the context of trigonometry. So let's look at example 4, where we are asked to graph y equals cosine of x minus pi over 4. So here's my y-axis, here is my x-axis, and we know that the period for a regular cosine graph is equal to 2 pi. And we know that if we were to graph one period, we would graph it on the interval 0 to 2 pi. And so the thing inside of the parentheses that we are taking cosine of, we want that thing to be within that interval between 0 and 2 pi. And so if we're solving this for x, we could add pi over 4 to all sides of this inequality. And if we do that, we get pi over 4 is less than or equal to x, which is less than or equal to 2 pi is the same thing as 8 pi over 4. And if we add pi over 4, that will result in 9 pi over 4. So when we are graphing our function now, normally we would start at 0, but now our left endpoint is going to start at pi over 4, and then our right endpoint will end at 9 pi over 4. So we have to take that into consideration when we are creating our x-axis, because normally the values that we are looking at are 0, pi over 2, pi, 3 pi over 2, and 2 pi. But now we need to add pi over 4 to all of these. So I'm going to quickly do this addition. So I've gone ahead and I have added pi over 4 to all of those angles that I normally use when I'm graphing sine or cosine, and those are now what are going to be placed on the x-axis. So I'm going to go ahead and place those values on the x-axis. Okay, so now that I have my x and y-axis filled out, let's start to plot some points. Now let's plug in pi over 4 and see what our output is really quickly. So if I plug in pi over 4 for x, that ends up being cosine of 0, which is equal to 1. So I'm going to go ahead and place that there. And if I plug in 3 pi over 4, that ends up equaling cosine of 3 pi over 4 minus pi over 4 is 2 pi over 4, which is the same thing as pi over 2, and I know that that's 0. And I'm going to go ahead and plot these other points, and so my graph is going to look something like that. And so, again, to reiterate, how we can see our phase shift on the graph is normally cosine starts here, and it would look something like this. So here is, let's see, what's between 3 pi over 4 and 5 pi over 4? That would be 4 pi over 4, which is the same thing as pi. 2 pi would be right here, and our graph would look something like this. So basically what's happening is everything was shifted pi over 4 units to the right. So the distance from here to here is pi over 4. And that is our phase shift.